I'm here with Scott Bleisath. So Scott, tell me a little bit about yourself and what you're doing here at DRATS.
Okay, well, I'm a systems engineer at the Glenn Research Center in Cleveland, Ohio, and we are working on the EVA backpacks that are used here in DRATS. EVA is extravehicular activity or spacewalk, and we've provided electronics or avionics that are on board the backpacks.
So tell me a little bit about the capabilities of these. What kind of things will these electronics be able to do? I see you got a piece of it on your arm there.
Yeah, we have a wrist display, or we call it a cuff display, and it's a flat panel display. One of the things that's unique about it is that it's not powered up right now, but it's a sunlight readable display, which if you ever use your cell phone on a bright day, sometimes it's hard to read. This has a technology that makes it very readable while you're in direct sunlight. And so this allows us to display procedures that the astronauts would use during the spacewalk. It also displays maps. It keeps track of your position. It's hooked up to a GPS that's on the backpack, and also allows us to record what's called field notes. So if an astronaut comes across a point of interest, a rock or some observation that they want to record, there's a note button here, and this is controlling a camera, a video camera that's on top of the backpack. Allows them to record some observations, and then at the end of the spacewalk, this information gets sent to the rover, and then the rover sends that down to the Mission Control Center.
Cool, that's really interesting. So an astronaut just on the fly in the field can, if they see something interesting, can just record its position and take a picture of it.
Right, so yeah, you control both a video camera and a still camera. And actually, basically, you're picking up rocks and you're holding it up in front of the camera and recording. A lot of times geologists, a lot of the data that they collect is just their voice being captured on a recorder.
Right, really cool. So so how much does everything, like the backpack and the armband, how much does about everything weigh when you put it together?
Well, the backpack is, we have a couple different configurations, but in general it's about 35 to 40 pounds.
Okay, cool. And so what are you trying to accomplish here during the dry runs to help prepare you for the field testing?
Well, this is the first time that we've had an opportunity to get the backpacks out. We actually collaborated with the Kennedy Space Center. They built the majority of the backpack, and then they integrated our system on board the backpack. So this is the first time that we've actually been able to get all the pieces together, and then we're going to start running some tests to test out how the data gets transferred, gets recorded on the backpacks, and gets transferred to the rover.
Very cool. And just to finish up, could you tell us a little bit about what your path to NASA was and how you got to where you are?
Well, I think that I first became interested in the space program. I was very young and still remember a little bit of the Apollo missions. But that I really became interested in high school when the space shuttle program started up. When I was in college, I went into engineering, aerospace engineering, and started working down here at Johnson Space Center when I was 19. That was quite a few years ago, as a co-op student, working here and going to school. And had a lot of fun for about 20 years working here, training astronauts on how to perform spacewalks, EVAs, and also working in mission control. 2 years ago, I transferred to the Glenn Research Center in Cleveland, where I've been working on developing the new generation spacesuits.
Well, thank you so much for joining us today. Be sure to stay tuned for more updates as we continue the DRATS dry runs this week and in the coming weeks, and we'll have more information and a more detailed look at the backpacks he was talking about later. Until then, I'm Ben Peters. Goodbye. That's right.